Moses were able to do the what's called obviously draw your triangle. What is it? 2, 3. What's the next one? Minus 1, 4. 6. Okay, and you're done. Right, there's your A, your B, and your C. Okay. The next thing is it goes using slope show that AB is perpendicular to AC. Okay, slope formula being y2 minus y1 over x2 minus x1. Did everybody get minus 1/3 and 3? Yeah. Did everybody get that? Right. If you didn't, alright, it's basically the first one. AB is going to be 4 take away 3 over minus 1 minus 2. You get minus 1/3. Slope of AC is 6 minus 3 all over 3 minus 2, which is a slope of 3. Now, you might want to write this into your tables right now. You're meant to get both slopes and multiply them by each other to prove that they're equal to minus 1. When you do this, this proves that the slopes are in fact perpendicular to each other, which means they're at 90 degrees to each other. So anytime you're asked to prove that two lines are perpendicular to each other, you can either prove that the angle in between them is 90, or you can prove that when you multiply both slopes by each other, you get minus 1. Question? If you so minus 1/3, if you flip that, then minus 3. What to say? If you turn upside down and change the sign, it's minus 1. It's minus 1/3 turns into 3, or 3 turns into minus 1/3. But that's not what gets you marks. What gets you marks is multiplying both slopes by each other and getting the answer equal to minus 1. Okay, and it's the perpendicular. Did anybody get full marks for that one? Yeah. You did M1 by M2? Perfect. If you didn't do M1 by M2, you didn't get full marks. Let's move on. Okay, next part. What now, guys? This is just, lads, in a nutshell, it's just this formula here. Okay? This is on junior cert ordinary level. You guys aced it at junior cert ordinary level. There's no reason why you can't ace something like this right now. Okay? So what you're going to end up getting is, did most just get root 10 for both of them? Okay? Lads, I'm just speeding through the stuff that we've been doing since junior cert, right? I don't really think it's worth spending too long on. Okay? And then the other one is, it's 3 minus 2 squared, and then 6 minus 3 squared, and that's also root 10. If you're wondering where I'm getting the numbers from, it's A is 2, 3. Yes. Which one? Oh, it's a minus 1, minus 2. Give me a second. For me, no, but for you, yes. You can do it 2 different ways. Okay, the main thing is we both got root 10. That's the main thing. I switched around my x1s and y1s compared to what you did, so that's why we have disagreeing answers. So, for instance, I think I did this is x2, y2, and b is x1, y1. Well, Daniel, you'll have it the opposite way around. You'll have b is x2, y2, and a is x1, y1. Everyone on board so far? Have you done anything that's ridiculously tough so far? You've got to get all them right. Okay? There was nothing there that requires any real thought that you didn't know in second year of school, right? Next part, fair enough. Right? You know that this is root 10. So what you've now discovered is this is a right angle triangle. Okay? And the right angle is here, isn't it? Okay. Now, oddly enough, I drew that slightly wrong, believe it or not. I lost marks, went too fast. See C? C should have been, C is slightly here, isn't it? So actually, went way too fast. There you go. Now it looks more like a right angle. Okay. Lads, you know this is root 10, you know this is root 10. And then you know a half base times height, only for a right angle triangle, can get you the area. So it's going to be a half base times height, which is a half root 10 by root 10. The answer is 5. Who got that one out? It's 30. What did you do? Oh, you rounded off. That's fair enough. Try not to round off the surds until the very end if you can. Alright, so lads, I'm expecting you all like to be on very high marks in this type of question right now. Right? There's nothing really outside junior cert there. Now this is the only part. And we've been cleaning up on these recently. Now the reason why you can't do that, John, is read the language. Hence using your answers in B part 2. Use the answers in B part 2 to do B part 3. It didn't say hence or otherwise. You get what I'm saying? So you would have lost marks even though you knew what you were doing. You get what I'm saying? You gotta be really specific on the language. Alright. Now lads, I have 2, 3, and does anybody remember the method for this? Yeah. Okay, I'm gonna ask Dermot, do you know the method for using this formula? Yeah. Done a few of them over the last couple of days. Yeah, to 0, 0. And there was nothing stopping you from doing part C. There was nothing preventing you from doing part C. You could have got everything else wrong, and you could still get part C right. Just use the formula. And then that's take 2 away from x, and what's it to y? Yeah, so what's the next point then, Dermot? Yeah, and the other one? Okay, so it's a half. Now, this is the type that's in section 1 of the Leaving Cert. Section 1 of the Leaving Cert is they're easier type questions. And we do something like this. Insert it into the formula. I got a half minus 10, which is 5. I had to get 5, didn't I? Because it's the area of the same triangle. Who got that one right? So you guys are on full marks for the fourth question. Awesome. Full marks there. Great. All right. So section A is easier than section B. Section B, you're going to have choice in, aren't you? What did I say your choice was? 2 out of 3? 6 questions do 5, and in part 2, 4 questions do 3. Okay. So this is Alright, just wondering what's going on with the there we go. Right. This one was tricky in a weird way, as in see why you have C and A? Yeah? See why you have C and A? You can use the distance formula, can't you? And you can find out the radius. Or you could use Pythagoras theorem, which is 3 up, 4 across. It's your choice. No matter what, the answer is 5. Who got that? Now, there should be more of you who got that. It's the centre of the circle to a point on the circle. Use the distance formula. Alright? I didn't get A if you didn't have. Well, not that one, like one lower down. Yeah, I'll keep going. Just relax. We'll sort it out. Alright? And then 3 minus 0, and the answer is 5. Okay? Now, this is an interesting one as well. Equation. So, we only ever use H and K, don't we? We don't use the G and X. Okay? So, Peter, what did you get for this? I got 25. But what did you get before? What's the centre of the circle? Yeah, x minus 4 to be squared. Plus y minus 0. You're allowed to write that. It's no bother. And equals 5 squared. The radius is 5. And x minus 4 squared. Oh yeah, sorry, you probably said 5. I heard 4. Alright. Grant. Who got that? Peter, right? So a few of us got that, right? So once again, we're expecting you to put away that part A. Part A is easier, right? Now, here's where this is an interesting little one here, okay? So there's 2 ways of doing this. I'm going to show you both the difficult and the easy way of doing this one. You need to know both methods, okay? So I want you to be amenable to learn about methods of, because sometimes they don't give you a choice and you need to use method B. Now, method A is the easiest way. Right? Get this. That's the point B. That's the point C. How far to the right is B compared to C? What's the radius? So Add 5 onto 4, 0, and what you get? Add 5 onto 0, and what you get? You get 9, don't you? So the answer is 9, 0, in a nutshell. Who got that? Awesome. Did anybody do it a different way? All right. So Peter would have done a bit of revision on this, and the way the book does it is like this. The book does it is that if you take the two, see the two green points, see the two green points, y is guaranteed to be 0 for those two green points. Do you get what I'm saying? Why is y guaranteed to be 0? It's on the x-axis. Okay. Next thing is, if I take this equation, which is x minus 4 squared, plus y squared equals 25. If I replace y equals 0 into that, what would happen is I then get x squared minus 8x plus 16, bring over to 25. I've replaced y with 0. I get this equation here. And this is the method I need you to know, because this method does a lot of questions. And then it's x minus 9, x plus 1 equals 0. And then you get x equals 9, which is the point B. We also get x equals minus 1, which would be the other point as well. Your choice. Sometimes there's an option and sometimes there isn't. In this case, there was no need to do this. There was no need for it really, was there? If you knew the other way, there was no need. But that method is important. If I ask you where does it cross the y-axis, what would you do? If I ask you for the two purple points or the two pink points, what would you do there? You put x equals 0 and then you solve a quadratic equation using the y. Exactly. You need to remember that, okay? It could happen. Now, we found out what b is. Is everybody cool with that? 9, 0. All right. Who got 9, 0 again? Peter. All right, good lads. Well done, Daniel. All right. Now, next thing is I have two different ways of doing this. And I'll show you both methods now. All right. I'm going to take a picture of this for you. Here. All right, guys. All right, we'll go for the easiest method first, okay? All right. The most, Peter, did you get the answer for this one? 143. Yeah, it's 143. Great work. Right. Here's how I do this. I know A to C is 5. Would everybody agree A to C is 5? Would everybody agree B to C is 5? Okay. Would everybody then agree that if I found out what A to B was, if I found the length of A to B, I could use the cosine rule to find the angle. So that's what I'm going to do. Do you do it that way? I have another way to do it as well, which is pretty good. But here's what I'd recommend you do. I'd recommend that you put in A. What's point A again? 0, 3, is it? And what's point B? 9, 0. 9, 0, okay? You can do the distance formula. Does everyone know how to use the distance formula? Or just to skip it and just give you the answer for the distance? Alright, the distance is 3 root 10 when you do the distance formula. And the distance formula is that one there from junior to second. Okay? Now that I have that, I'm going to use the cosine rule. Is that alright? I'm going to use the cosine rule. And what's the cosine rule? A squared equals e squared plus c squared minus 2bc cos A. This is quite difficult. Alright, so what do I put in for A? What angle do I want? I want ACB. Which one's ACB, lads? The one that's shaded in? The yellow one, or the one that was shaded in black. Oscar, what's small a for this question? Small a. No, it has to be opposite the angle. The angle has to be looking at it. Oh, I did actually write that. So 3 root squared, yeah. And then 5 squared plus 5 squared minus 2 times 5 times 5 cos A. Peter, I'm about to do this here. Can you explain why I'm about to colour this in? And this is the way I taught you initially. Why do I have that coloured in? You have to leave it alone until the very end. It's bonded by multiplication. which means you can't do anything to it until everything else is sorted out. Okay, and that's 90. So what do I do with the 50 here? And you get 40. What do I do with the minus 50? It's multiplication on the right, which will make it division on the left. How do I separate A from cos? No, multiplication turns into division. Addition turns into subtraction. So it stays as minus. If you wanted, you could multiply both sides by negative, Sam. And then you could get that. And then you just bring the 50 underneath. And you get the same, roughly the same thing. All right. John, how do you separate cos from A? And it is shift cos inverse and then minus 40 over 50. And you should get yourself 143. Go, you guys. All right. For those of you who got that right, here's another way you could have done it. Peter, you looking? Another way we could have done it was this. I could have made a right angle triangle, like so. See that right angle triangle? Okay. And what I know about this right angle triangle is it has a length of 9 and a height of 3. And I could have found out this little angle in here. Because it's an isosceles triangle, because the two radiuses are the same length. Plus tan inverse 3 over 9. And I tan inverse 3 over 9. This is a much shorter method actually. If I tan inverse 3 over 9, I got 18.4. 3, yeah? And then if I multiply that with 2, get the two green angles added together and take it away from 180, it works out really, really easily. So 180 minus 2 times my answer, and that would give you 143.13 in 2 quick steps. But the other method is the more conventional method. So one more time for anybody that doesn't remember. That crosses at 9, 0. That makes this distance 9. That crosses at 0, 3. That makes that distance 3. I can tan inverse because it's opposite over adjacent. Tan inverse it to get the green angle. It's an isosceles triangle because there's two radiuses. That means those two angles are the same. Okay? Then I can find the other angle that way. Anybody get 143 bar, Peter? Daniel? Then we lost you guys now, did we? But you can still get marks with a wrong answer if you get what I'm saying. Just make up an answer to this question if you have to. Right? Next part. All right, this one. This is tough. Right? So let me. There you go. Right. Get this. All right. Once again, here's what I suggest. I suggest you get the area of the blue triangle and you add it on to the red pizza slice. Does that make sense? Blue triangle plus red pizza slice will give you the answer you're looking for. Let's get some attempt marks on the board. What's the area of the blue triangle? A half. What's its base and what's its height? What point is 4 is the base and its height? So I have 3 by 4 will get you 6. No, because the radius is that's 5. That's 0, 0. That's 4, 0. So it's a distance of 4 away from it. Now, if you go to your maths tables and you go to page, I think it's page 9, you're going to see something. So if you're ever looking for the area of the pizza slice, there it is there. See this formula here? Page 9. That's a bit loud. Alright, so what can I do with this formula here? We're talking about the red pizza slice here, Peter. Yeah, go on. Pi times. What's the radius, Peter? Of the circle. The radius not 5. The radius of the circle. So pi times 5 squared. What's the angle for the pizza slice? What we got in the last answer. Okay, you throw all of that into the calculator. What you get? Yeah, lost it. Where did I put it? I got 31.2. You got 30. Oh yes. Yeah, I see it now. Yeah, good man. Plus 31.2 equals 37.2. I actually got that one wrong, Peter. I added on 12 for some reason. You got that? Yeah. Full marks on that one. Jeez, that's impressive. That's a tough question. Very impressive. You're obviously counting it, right? You're not counting that? You want to be if you're putting that much work into it. All right, guys. Lads, we're going to do Pythagoras' theorem. Okay? Please make sure 127 is on its own, and the 120 and the x are over to your sides. You do 127 squared, take away 120 squared, and what you should get is 1729 equals x squared. Square root it, and you get x equals 41.58. Okay, so now you know that that is 41.58. We good so far? All right. Next thing, A part 2. Show that the angle CAB is 19.1 degrees. What angle is CAB? There, it's angle X there. All right. Here's the deal. You can use sine, cos, or tan. Why? Because you know all three sides. Doesn't matter which one you use. Now, I've been inclined to use cos because they're the original two numbers, aren't they? So what I just say is cos x equals adjacent over hypotenuse is adjacent is 120, opposite is 41.58, and hypotenuse is 127. So I'm going to use adjacent over hypotenuse, which is 120 over 127. Sam, Cassie, how do you separate cos from x? Cos inverse 120 over 127, and you get an angle of 19.1. So x equals cos inverse 120 over 127 equals 19.1. Now this one's going to annoy us, right? This one's really going to annoy us. Can anybody tell me how to find out what A is? Max. You do. Well done, Max. All of these combined. Mako. Alright guys, look at this. Alpha plus 19.1 has to equal 90 degrees. So 2 alpha plus 19.1 equals 90 degrees. Take away 19.1, and you get 2 alpha equals, what was it? 70.9. And divided by 2. And we get 35.45. Dan, you got it as well? See the way they're just handing you those three. Right away, get some marks on the board, right? Now, find the area of ABC. Which one's ABC? Lads, take your choice. Alright? You could use, are you ready? Peter. You can use a half base times height. You can use a half 120 times 41.58. It does say trigonometry though, doesn't it? That's technically geometry, so I would also put down this to cover me. Half, sorry Paul, half two sides, the angle in between. So what would you choose? A half two sides and the angle in between. Could you use that one? Could you use a half 127 times 120, sine 19.1? You can use either of them. And what will your answer be? What's the answer no matter what you do? what's it? 22493.4. Who got that? Fine, did you not? No, that's fair enough. Alright. I'd imagine you'd all clean up there as well. Right? And right. Huh? Yeah, you could, yeah. Fair enough. Alright. The area of ACD is twice the area of the triangle ABC. So what do I need to do with this area? Multiply it by 2. I get 4,986.8. Oscar, I'm now going to look at ACD. So what is ACD? Let's find out. A to C to D. It's the blue triangle. What do we know about the blue triangle? We know that angle, don't we? 35 points, 4, 5, and we know one of the lengths is exactly, all right? So what I'm going to do is I'm going to do half AB sine C equals 4,986.8. And then I'm going to do a half A is going to be 127. B is what we're looking for. We need to find the length. We know the angle in between, don't we? Sine 35.45. We know equals this. So, what does that mean then? What does it mean, guys? Peter, any idea? Alright. First of all, divided by 127 and divided by sine 35.45. Okay. And on the top, multiply by 2. And your answer will be 135.4 meters. Alrighty. Stop there for a second.